All right, we're going to start chapter 2.1 today, increasing, decreasing, maximum, minimum. After this, I'm pretty sure we're going to do a test sometime this week. I think we'll do increasing, decreasing, max, min. We'll do some homework over it, and then we'll review and test. Probably it'll be today notes, tomorrow homework-ish, and then Wednesday review, Thursday test. That's what I'm thinking. And then we're going to start a project. Oh, no. We have to do notes. We'll probably be doing notes on Friday, so please try not to miss on Friday. So, now, uh-oh. Okay, let's exit out of this and try again. There we go. Okay, increasing, decreasing, max, and min. So here, when we're talking about increasing, this is going to be going up when you move your pencil from left to right, right? And then decreasing is going down when you move your pencil from left to right. Always got to think about left or right. Also, when we think about this, if you have this and you have an arrow down, ignore the arrows. The arrows do not have anything to do with whether this is increasing or decreasing. In this case right here, if you move your pencil and you trace this from left to right, we are increasing, right? So you got to kind of keep that in mind. Ignore the arrows. This is an increasing. So make sure you ignore the arrows, because that doesn't mean whether you're increasing or decreasing. You just got to move your pencil from left to right, up or down, okay? Now, so when we talk about this, we always do increasing and decreasing in interval notation. But remember, with interval notation, we have to decide whether to use brackets or parentheses. Now, when we talk about maybe an absolute value function like this, absolute value makes a V. So you know that right here, if we're going up left to right, what is that? Increasing or decreasing? Increasing, right? And then on this side, we're going down if we go left to right. So that one is decreasing, right? At this point right here, that point right there, is it increasing or decreasing? It's not really doing either, right? It's the change point. It's where we're changing from increasing to decreasing. Does that make sense? So will we include that as increasing? No. Will we include that as decreasing? Also no. So with these, this is neither, right? It's a change point. So here, just kind of as a reminder, we're going to use interval notation, and we will always use parentheses, right? Because it's a change point. That's why we're always using parentheses. And then we will always use the X values. That is the thing that people get wrong on this, is that they try to use the Y values because they're thinking about how high or low we are. This is not it. This one, we always use the X values, sorry. X values. Always, always, always use X values. The X values of the ordered pairs. So if you need to, do the ordered pairs and always use those X values. So here, relative max, relative min. Okay, this makes sense. Maximum is the highest point. It's higher than all the points around it. So the relative maximum is higher than all the points around it. And the relative minimum is lower than all the points around it. All right, it says determine the intervals on which the function in the figure is increasing, decreasing, constant, And then, okay, obviously we didn't define constant, but I mean, you know that constant is when it's not going up or down, it's just flatlined, okay? So then it says state the relative maximum and relative minimum. Now, something you may have also looked at is global maximum and minimums. So if we just kind of like side note here, if we look at this, all right, this function is a cubic function, right? It looks like an x cubed. It doesn't have a global maximum. So a global maximum is the highest point of the function ever, right? This point is a relative max, okay, because it's higher than all the little points around it. But there's not a global max because this does keep going up and up and up and up and up. But if you looked at something that looks like this, next to the fourth function, this one is a global minimum. Okay, this is a global min. So when we have a global minimum, that means it's the smallest point ever. But there's also a relative minimum here. So global is also a relative, okay, but relatives are not globals. Think about global as entire everything, right? Relative is just within this little bubble that we're going to draw, okay? So here we are going to do increasing, decreasing, maximum, and minimum, right? Increasing, decreasing, max, min. Increasing, decreasing, constant, sorry. And we'll look at the maximum in a second. So the first thing that I would probably do is go through and put these ordered pairs down. I would go through and look at these ordered pairs. I know it's kind of fuzzy and I know it's not super clear on your graph, so that's why we're going to go through and put our ordered pairs down. So this ordered pair right here, this is x is -8, y is 2. So this is -8, comma 2. -8, comma 2. All right. Now down here, so I'm going to do it at every ordered pair where it changes from increasing to decreasing, decreasing to constant, constant to any of that, right? So this ordered pair is -6, comma -2. This ordered pair is -3, -2. Oh, sorry, -3, -2. And then this ordered pair is -2, comma 3. All right, so I'm going to go ahead and do those. So here, at each of these points, right, at each one of these points, we change from increasing to decreasing, decreasing to constant, constant to increasing, increasing to decreasing, like any of that, right? All of these places are where we change, right? Okay. So let's look at each thing inside of there and decide whether it's increasing, decreasing, or constant. So if we look at this left portion right here, what am I doing on my graph if I move left to right? Am I increasing, decreasing, or constant? Increasing, even though the arrow is pointed down. Like I said, ignore the arrows. So I'm just going to put a little I right here. I for increasing. What about from -8 to -6? What am I doing? Decreasing, good. And then from -6 to -3, constant. From -2 to -3, and then from -3 or -2 to infinity. This is a constant. All right. So now that's what I always like to do first. Is I always like to like graph it and then label them and then decide what we're doing. These will be intervals of x values. So if I talk about intervals here, all right, this interval right here, x values only. If I look at this interval up here, where do we start? Where does this interval start at? Where does this interval start at? So negative 13, will this keep going down forever? And that way forever? Yes, so not just negative 13, negative infinity. So we're going to start at negative infinity. Where does this increasing interval stop right here? At, what's that x value? You wrote it down. Negative 8, good. So that's where it stops. So negative infinity, comma, negative 8. Again, are we going to include that negative 8? No, because this point right here is a change point. You are neither increasing nor decreasing. Never include infinity, and negative 8 is not going to be included that way. All right, so now if I look at this green interval right here, this is an interval that I'm decreasing over. Where does this green interval start? What x value does it start at? Negative 8, comma, where does that decreasing interval stop? Negative 6. Right? So keep that in mind, that this is always going to be x values, never, never, never y values. All right, now what about this interval right here? So this blue interval we're constant over. So where does that blue interval start? It goes to? Good. And then I'm going to have a pinkish interval right here where we're increasing, little teensy tiny one. I'm going to put it up here. All right, where does that little teensy tiny interval start at? Negative 3 and end at? Good. And then lastly, I'm going to do another yellow interval. Here, this one, we're all the same. Where does this constant interval start at? And then goes to? Always use parentheses again, because at this point, we are neither increasing nor decreasing. Okay, now you really just have to match the intervals. Okay, so here, we are increasing at the first yellow one and at the pink one. So we are increasing from negative infinity to negative 8, comma, and, right, we are increasing from negative 3 to negative 2. Does anybody not understand where I got those things? Good? All right, we are decreasing. Now we are only decreasing once, and we already labeled it, and it's this green one right here, right? So we are decreasing from negative 8 to negative 6. Bless you. Also, in your homework, it might ask you to join these with a union. I can't remember. One class does it one way, one class does the other way for some reason, because the books are just a little bit different. So, lastly, the constant, we have this blue one and this yellow one are both constant. We've already labeled them. So constant is negative 6 to negative 3, and oops, that's not a 3, and negative 2 to infinity. There's our increasing, decreasing constant. Now you can definitely do this as you go along. You can say, okay, here's increasing, negative infinity to negative 8, then any of that, that's fine. I like to do it this way so you remember it's x values, all right? So let's look at the next one. All right, so these already have the ordered pairs done for us. I want you to go ahead and decide, do this on your own. Decide which one is increasing, decreasing, and constant. Okay, just write on there, I, C, or D. Go ahead and do that on your own. All right, check your answer up here. Again, you need to ignore the arrows. Ignore the arrows. Just because the arrow's facing up does not mean it's increasing. If you move left to right, you are decreasing, constant, increasing, then decreasing. All right, I'm going to add my little dashed lines here. Not perfectly straight, but they'll do. All right, so this one, okay, this first interval right here, first interval that we are decreasing over, where does this interval start and stop? Good. Negative infinity to negative 1, parentheses or brackets? Both, right, on both of them. All right, what about my next one, my constant? Where does that one start? Negative 1, right? Where does it end? 3, parentheses always on these. Now we're going to do a blue one. So our blue one is increasing, and we are increasing from where does this one start? 3, where does it end? 5, 3 to 5. And then the last one, where do we start on this one? Good, to infinity. Okay, something to keep in mind is something to kind of like check yourself with is that notice that when you have each one of these, this makes a full negative infinity to positive infinity. Negative infinity to negative 1, negative 1 to 3, 3 to 5, 5 to infinity, right? If they don't connect without any holes besides like their little join parts, then you did something wrong. Probably used the y values. If you use the y values, it's going to have big jumps in your things, right? Okay, here, let's look at our increasing, decreasing, and constant. Oh, y'all real quick, write these down. The bell's about to ring. Y'all go ahead. Do this one on your own. Finish it out. All you got to do is match it up. We'll finish this tomorrow. All right, is there any questions about this one? You might not understand something about these. Literally all I did was write down the intervals, what we did a second ago. All right, now for both of these, it says go ahead and state the relative maximum and minimums. All right, so I'm going to go back and look at the other one. Don't worry, I'll come back to this one if you're not finished writing. Okay, I'm going to go back and look at the other one. Uh-oh. Let's see. All right, go back and look at this one. Okay, I know I have a lot written on here, but do you see any relative maxes or mins? Do you see any maximum or minimums on here? Do you see a maximum?
Is there also a global?
Well, okay. Some books say yes, some books say no. So we'll talk about that. But this is a maximum right here, this little red one that I have circled, this 8, negative 8, comma 2. Now, that is a maximum, a relative maximum, because it is higher than all the points around it. If I kind of like draw a circle around all of its friends right around it, it's higher than all the points around it. So we have a maximum at the ordered pair, negative 8, comma 2. Now, here's the problem. MyMathLab won't ask you to write it like that. It asks you to write it very strangely. Okay, so I'm going to show you this. It's going to say, now the maximum is, what is the highest value? So if I ask you, what is the highest value? Are you going to tell me an X value or a Y value? A Y value, right? So that's what we're going to say. The maximum is 2. All right, the maximum is 2. And where does it occur? That's the X value. So it's at X equals negative 8. All right, but if it just says type integers, just say this. The max is 2 at -8. Okay, this is going to be the hard part for you to remember. So I'm going to go up to the top here again, and I'm going to write that over here. So the maximum, the max or min, right, slash min, is the y value at the x value. Okay, the maximum is the y value at the x value. Okay, what is it is how high are we? All right, where does it occur? Like, where is it at? That's the x value, how far left or right we are. All right, so keep that in mind. Okay, now this one, okay, let's talk about this point right here. So, is that point higher than all the points around it? No, it's not, right? This little 2, -3, it's the same height as all of those points right there. So, by the definition, is that a maximum? No. However, some books would call it a maximum. It just kind of varies from one to the other. Our book does not call that a maximum. They just say in this case there's no max, no global max, right? Because it just keeps going. But same thing with these. Are these two minimums? No, because they're not lower than all the points around them. They're the same as some of the points around them. So this one, there's no minimums. No min. Okay, that one has no minimums. Let's look at this friend over here. Does this one have any minimums? Does this one have any minimums? No, no minimums, because these two would be our minimums, but they're the same as some of the points around them. They're not lower than all the points around them. So there are no minimums. But is there a maximum? Yeah, it's at this point up here, right? This 5,2 is higher than all the points around it. So we have a maximum, and our maximum is, okay, how high are we? What is the maximum? What's that maximum? Yes, 5,2, but if I asked you to do it like we did earlier, how high are we? 2 add x equals 5, yes. The maximum is 2, and it occurs at 5. So sometimes it'll say where at is the maximum. Just make sure you look for the word at and the word is. Those are the key two words here. All right, any questions about these two here? All right, let's flip to the back real quick. Go ahead and flip to the back of this paper. Now, I want you to do this one on your own. Okay, see how it has the at and is words? Be very careful with the at and the is. At is x, is y. All right, at is x, is y. So see if you can do max and min, and then do increasing and decreasing. Right? See if you can do those guys. If you finish this one before I finish it up, go ahead and move on to the next one. All right, this one, make sure you remember, has a maximum. The maximum is -1. That's the height of it. It occurs at -8. That's the x value, right? And then we have a minimum at -4. That's where it occurs at. And the minimum is -9. That's how low we are, right? If we break it up to increasing, decreasing, we are increasing on the left, decreasing in the middle, increasing on the right. Then you increase from -8 or negative infinity to -8 and -4 to infinity, and we decrease from -8 to -4. Any questions about this one? All right, go ahead and do the next one on your own. It's the exact same thing. Next one on your own. Exact same thing. Okay, this one, the only difference with max and mins on this one is that this one has 2 relative minimums, and a lot of the times they'll just say, okay, separate the x and y values by a comma. So here we have 2 relative mins, 1, 2, and then they're at -3 and 3. Now the relative minimums are 0. If they were 2 different numbers, they'd say, okay, put the smallest one first or something. Just make sure you follow those directions. All right, do the increasing, decreasing if you haven't yet. All right, are we good? Any questions on this? Anybody not understand? All right, so now that we have this, I want you to be very, very, like, you have to know increasing, decreasing, max, min. That's kind of like things that you've gotta know. All right, so now, yeah, let's go ahead and we're gonna flip back and do the other one. This is a calculator problem. So I know you guys, if you have your calculator with you, you can go ahead and pull it out. Or if you're on your computer, you can pull it up. But we probably will have time to do the first one, and then the second one we'll do tomorrow so that we can so that y'all can practice on your computer one. So if you have your own, go ahead and take it out. If you don't, or if you don't want to, you don't have to. But this guy, it's again asking for it's asking for increasing, decreasing, maxes, and min. So here, I already have stuff in here from dual credit. So if you have stuff in y equals, then go ahead and clear it out. So what we're going to do is go ahead and put that in. So negative x squared minus 8x, and then minus 9. Make sure you're using the minus and not the negative. And then let's graph it. So if we graph it, there it is. Now, if yours is very weird and it's just like you can't see something or something like that, remember, if you hit zoom 6, and zoom 6 says zoom standard, it'll give you that 10 by 10 graph like normal. Mine was zoomed down a little bit because I needed it to be for my other class. So zoom 6, if you need that, zoom 6 resets the graph. I'll write that on the side here. Zoom 6 resets the window to 10 by 10 if you need it to do that, right? So here, the first thing that we do is, so once we put it in y equals, like that's an obvious one. You got to put it in y equals. So the first thing we do is do second calc. We either look for the maximum or the minimum. You have to tell it, max or min. Then you're going to do left bound, right bound, and guess. Okay. So before we can do increasing and decreasing, you need that turning point or the max or min. You need that first. So this one, if we look at this, this has a maximum, right? So we're going to go second calc, which is right here above trace, right there. So second calc, we are looking for a maximum. This is an upside down parabola. So I am going to click number 4 or arrow down to number 4 and hit enter. Okay, now it asks left bound, right bound, enter. So notice I have a little blinking dot right here, blinking dot, right? We need to say, all right, where it says, where are you going to make me look? Where are we looking for the maximum? That's what it says. It says, I don't want to search this entire graph. I want you to tell me where to look. So all you do is you're going to arrow to the left or wherever until you're on the maximum or minimum, whatever you're looking at. All right, so we're kind of close there, right? This one, it wants you to go to the left. So I'm going to hit left arrow 3 or 4 times. 1, 2, 3, 4. So now my blinking dot is to the left of this maximum value. And then hit enter. Hit enter. There it goes. Now it says, oh, I want a right bound. Okay, so we got to go back to our point and then hit right a couple of times. So here's my right bound. See how my blinking dot is to the right of my maximum, and hit enter. Notice that you have these 2 little arrows. This is what it's saying. It says, okay, look between these 2 arrows, and they're facing each other. Would it make sense to say, look between these 2 arrows that are going opposite directions? No. If you make the arrows face opposite directions because you went right and then left and then made them go the wrong ways, it's going to tell you there's an error, okay? So make sure that your little arrows are pointing towards each other to say, look between me, look between me. So now your guess. All right, our guess is going to be somewhere close to the top, right? There's the guess of where I think the maximum is. So it tells the calculator where to start looking. Oh, there's my maximum. All right, now sometimes it'll do this. Negative 4.0000001. The calculator is like doing some approximations here, so it's wrong, kind of. It just gets close, and then it's like, yeah, that's where it is. It's not like exactly finding it mathematically. So if it's negative 4.00001, or some of you will get negative 3.99999999999, it's going to be 4. Okay, so just kind of keep that in mind. So this one, we know we have a maximum is negative 4, 7. There's my ordered pair. So if I had to write it, my maximum is, what is my maximum? How high are we? 7, and it occurs at where? Yes. All right. Now, here, this is the only 2 different points here, right? We are increasing and then decreasing, right? So if we kind of look at this, it does this. Okay, and here's my ordered pair, -4, 7. So here, we're changing here. So this part right here, we don't have any constant here. So this part to the left, are we increasing or are we decreasing? What are we doing right there? Increasing. So this is our increase. And where do we start increasing? Negative infinity. Where do we stop? Good. And then do we have any decreasing? Yeah, that's this side. -4 to infinity. Good. So this one, the other thing that I wanted to point out to you, this is our x value. So if we talk about -4 to positive infinity, just because it's arrowing down, you do not say negative infinity. That's another common mistake. It's x values. We don't care about which way the arrow is pointing. So our x value starts at -4 and goes to positive infinity. So -4 to positive infinity. Keep that in mind. All right, tomorrow we will do this one and the word problem, and I'll give you some time to work on homework.